Look at these two things. 3 to 4 and 3 over 4. Not only they look almost identical, but they use the same numbers as well. But in reality, they mean completely different things. And confusing them is one of the most common mistakes in grade 7 and 8 math. In this lesson, you will learn exactly how ratios and fractions connect, how they differ, how to convert between them, and how a ratio can secretly be a division problem in disguise. By the end of this video, you will never confuse them again. Welcome back to the Ratios, Rates, and Proportions series. Today's topic is ratios versus fractions. What connects them, what separates them, and how to convert between both. Let's start with the most important distinction. A fraction represents a part of a whole. When you write 3 over 4, it actually means 3 parts out of 4 total parts. The 4 includes the 3. It is the whole. On the other hand, a ratio compares two separate quantities. When you write 3 to 4, it means 3 of one thing, compared to 4 of another thing. The 4 does not include the 3. They are separate groups. Here is the clearest example. A bag has 3 red marbles and 4 blue marbles. 7 marbles in total. The ratio of red to blue is 3 to 4. Two separate groups being compared. The fraction of red marbles in the bag is 3 over 7, which means 3 parts out of 7. Notice, the fraction uses 7 as the denominator, not 4. And it's because the fraction refers to the whole bag, not just the blue marbles. This is the number one source of confusion. A ratio of 3 to 4 does not mean 3 over 4 is a fraction, unless it is a part-to-whole ratio. Now, here is where it gets interesting, because sometimes a ratio and a fraction do mean exactly the same thing. This happens when the ratio is part-to-whole. Remember, a part-to-whole ratio compares one group to the total. If 3 out of every 7 students are girls, then the part-to-whole ratio of girls to total students is 3 to 7. The fraction of students who are girls is 3 over 7. In this case, 3:7 and 3 over 7 mean exactly the same thing. So, the rule is simple. Part-to-part ratio, not the same as a fraction. Part-to-whole ratio is the same as a fraction. Let's work through a full example. A class has 12 boys and 18 girls. Question 1. Write the ratio of boys to girls. This is part-to-part. Boys compared to girls. So, it is 12:18 and simplified as 2:3. Question 2. What fraction of the class are boys? This is part-to-whole. Boys compared to total. Total students, 12 plus 18 equals 30. Fraction of boys in the class is 12 over 30 equals 2 over 5. Question 3. Write the part-to-whole ratio of boys to total students. It is 12:30 and simplified as 2:5. Notice, the part-to-whole ratio, 2 to 5, and the fraction, 2 over 5, are identical. But the part-to-part ratio, 2 to 3, is completely different. This is an exam favorite. Know the difference. Now, let's talk about converting between ratio and fraction form. Converting a part-to-whole ratio to a fraction is straightforward. The first number becomes the numerator. The second number becomes the denominator. 3:7 becomes 3 over 7. 5:9 becomes 5 over 9. 2:5 becomes 2 over 5. But converting a part-to-part ratio to a fraction requires one extra step. You must find the total first. If the ratio of boys to girls is 2 to 3, total parts, 2 plus 3, equals 5. Fraction of boys, 2 over 5. Fraction of girls, 3 over 5. The denominator of the fraction is always the total, not the other part of the ratio. Let's try a conversion example. Pay attention. The ratio of cats to dogs in a shelter is 5 to 3. Question 1. What fraction of the animals are cats? Total parts, 5 plus 3, equals 8. Fraction of cats, 5 over 8. Question 2. What fraction of the animals are dogs? Fraction of dogs, 3 over 8. Question 3. If there are 40 animals in total, how many are cats? 5 over 8 of 40 equals 5 divided by 8, multiplied by 40 equals 25 cats. Question 4. Write the part-to-whole ratio of dogs to total animals. Dogs to total, 3:8. Notice, the part-to-whole ratio, 3:8, and the fraction, 3 over 8, are identical again. Now, here is the concept that connects ratios, fractions, and decimals all at once, and most students never realize it. A ratio can represent division. 3:4 means 3 compared to 4. But it also means 3 divided by 4. 3 divided by 4 equals 0.75. So, the ratio 3:4, the fraction 3 over 4, and the decimal 0.75 are 3 different ways of expressing the same relationship. Let's try another one. The ratio 1:4. 1 divided by 4 equals 0.25. So, 1:4, 1 over 4, and 0.25 all mean the same thing. And one more, the ratio 2:5. 2 divided by 5 equals 0.4. So, 2:5, 2 over 5, and 0.4 are all equivalent expressions. This is why your decimal series and ratio series connect directly. The skills build on each other. Let's use ratio as division to solve a real exam question. 2 friends share prize money in the ratio 3:5. The total prize is $240. How much does each friend receive? Step 1. Find total parts. 3 plus 5 equals 8. Step 2. Convert each ratio part to a fraction of the whole. Friend 1 receives 3 over 8 of $240. Friend 2 receives 5 over 8 of $240. Step 3. Calculate each share. Friend 1, 3 divided by 8, multiplied by 240, equals $90. Friend 2, 5 divided by 8, multiplied by 240, equals $150. Step 4. Check, 90 plus 150, equals 240. Correct? This method, converting ratio parts to fractions of the whole, is the most reliable way to solve sharing problems on exams. Here is the most common mistake when mixing ratios and fractions. A question says, the ratio of orange juice to water in a drink is 2:3. What fraction of the drink is orange juice? A student writes 2 over 3. That is wrong. 2 over 3 would mean 2 parts out of 3 total. But the total is 2 plus 3 equals 5 parts. The correct fraction is 2 over 5. The denominator must always be the total number of parts, never just the other part of the ratio. This mistake alone costs marks on hundreds of exam papers every year. Remember it. Now it's your turn. Pause the video and solve these. Question 1. A smoothie has mango and pineapple in the ratio 3:5. What fraction of the smoothie is mango? And what fraction is pineapple? Question 2. The ratio of fiction to non-fiction books in a library is 7:3. If there are 200 books in total, how many are fiction? Question 3. Convert the ratio 4:5 into a decimal. Question 4. A sum of money is shared in ratio 5:7. The larger share is $84. What is the total amount? Pause now. Here are your answers. Answer 1. Total parts, 3 plus 5 equals 8. Mango, 3 over 8. Pineapple, 5 over 8. Answer 2. Total parts, 7 plus 3 equals 10. Fiction fraction, 7 over 10. Fiction books, 7 over 10 multiplied by 200 equals 140 books. Answer 3. 4 divided by 5 equals 0.8. The ratio 4:5 equals the decimal 0.8. Answer 4. The larger share is 7 parts equals $84. So, 1 part equals $84 divided by 7 equals $12. Total parts, 5 plus 7 equals 12. Total amount, 12 multiplied by $12 equals $144. Here is your final challenge, a multi-part exam question. In a school, the ratio of students who walk to school to students who take the bus to students who are driven is 4:5:3. There are 360 students in total. Question 1. What fraction of students walk? Question 2. How many students take the bus? Question 3. How many more students take the bus than are driven? Pause and solve all three. Let's solve it step by step. Total parts, 4 plus 5 plus 3 equals 12. Answer 1. Fraction who walk, 4 over 12 equals 1 over 3. Answer 2. Students who take the bus, 5 over 12 multiplied by 360 equals 150 students. Answer 3. Students driven, 3 over 12 multiplied by 360 equals 90 students. Difference, 150 minus 90 equals 60 more students take the bus than are driven. This is a three-part ratio problem using fractions, division, and subtraction together, exactly the type of multi-step question you will see on your grade 7 and 8 exams. So, today you learned the key difference between a ratio and a fraction, part to part versus part to whole. When a ratio and a fraction mean the same thing, and when they don't. How to convert a part to part ratio into fraction form by finding the total first. How a ratio represents division, connecting ratios, fractions, and decimals in one idea. And how to solve sharing and distribution problems using fractions derived from ratios. The next lesson is proportions, where we will see what they are, how to solve them, and how they connect everything you've learned in this series so far. Subscribe and don't miss it. And don't forget to follow us on Facebook, Instagram, and TikTok. Thanks for watching. See you in the next lesson.